Yes, good evening. Am I audible? Please let me know in the chat box. Yes, so let us start this session. In our previous session, we have discussed with our randomization, like what do you mean by randomization and what do you mean by pre-randomization, post-randomization, and how you're going to use them and how you're going to perform the randomization and all we have discussed it in our previous sessions, right? Now, in this particular session, let us try to start with the discussion of the topic which is known as constraints. Okay, so let us first of all try to understand what do you mean by constraint. Okay, so basically a constraint is like a condition, okay, which you are going to have. Constraint is nothing but a condition, right? So this is when you're going to randomize your data, when you're going to declare any variable and you're going to randomize your data, the data will be randomized and it is going to give you some random values. But if you want to generate your random stimulus, but in a conditional manner or in a constrained manner, you're going to use this constraints. Okay. In detail, when I'm going to discuss about test bench architecture, test bench driving, test cases development, there I will show you like how these constraints are being very useful. Okay, there will be something known as constraint based test cases, constrained CRV, constraint randomized verification we are going to use. There I will explain you. Okay, so now you can remember this constraints is nothing but your conditions which you are going to have. Now, how to use it? You are going to use a keyword which is known as constraint. This is the keyword which you are going to use, and followed by the variable name or the constraint name you can have. You can have the constraint name, whatever the constraint name you want to have, that particular thing, and followed by the curly braces you need to have. And in the curly braces, you're going to give whatever the expression or whatever the condition you want to have. That particular condition you can have over here. And the semicolon will be inside the curly braces, but not outside the curly braces. This is most confusing point. Even now, I feel this as irritating because semicolon we are use it to have outside the curly braces, right? So in the constraints, we are going to use the semicolon inside the curly braces. Okay. So this is how you're going to use a constraint. For example, let us see one example. Let's say if I'm going to have a simple class, let's say the class name is test. Okay. Here I'm going to declare a rand int a. A is one of the variable which I'm going to declare. Now here the condition I want to include over here is constraint, and the name of this constraint which I'm going to give is range or range underscore a. This is the constraint name which I want to give. Okay. And within a curly braces, what I want is the value of a should be less than 5. Whatever the random values that will be generated, but the random values that should be generated should be less than 5. That is what I'm going to give. Now, can anyone tell me whether the negative values will be given to a over here? Whether am I going to get the negative values here or only the positive values from 0 to 4? What do you think? Whether I am going to get negative values or only positive values from 0 to 4? What do you think? Negative values also, because int is a unsigned data type, right? So you're going to get the negative values to 4. Okay, you can get any values. Okay, so that is nothing but my constraint. This is how I'm going to use my constraint. Okay, so let's see some examples of how you're going to use your constraint. Let me open the playground and let me stop presenting. Let me share my screen again. Hope my screen is visible, right? Please confirm the visibility. Yes. So let me create a simple class over here. And let me first of all select the tool. Yeah. So let us write down a simple module top. And in this, I'm going to declare a class. And this class, let's say I'm going to declare a variable a. And here I'm going to write down one constraint. What is the constraint over here is A underscore range is the constraint name, and A should be less than 5. Okay. This is what I have written over here. Now, and followed by end class. Now, for this class, within an initial beginning block, what I'm going to do is I'm going to create a handle. So I'm going to create a handle for this class test t underscore h. Next, what I'm going to do, I'm going to create a memory for this. And next, I'm going to create the randomize method t underscore h dot randomize. And let me display the value of a so that we can see dollar display. The value of a is percentage d comma t underscore h dot a. And this particular process, let me repeat for some 10 times. Okay. So repeat of 10, begin and end. Okay. And let me run this. So I'm basically randomizing my variable for 10 number of times. Let me see what I'm going to get. So see, I'm getting negative values also over here, and negative values and positive values. What is happening is less than 5. Yeah, I'm getting all the values as negative only, no positive value. And if I'm going to give one more condition, like let's say suppose uh, a is greater than 0 and a is less than 5, then the values between 0 and 5 will be printed. So see, so the values between 0 and 5 will be printed like this. So like this, we are going to generate the random values, but the random values also we are going to give some conditions over here. That is nothing but my constraints. Is it clear? Any doubts or any queries in this? Okay, that's great. Yeah. Now, now let us see one scenario over here. Let's say if we have a particular constraint declared like this. Let me show you one scenario. Let me keep the slide show. Let's say in a particular class, if I'm going to have one constraint, let's say constraint range underscore 1. This is one constraint which I'm going to have, where in this particular constraint, I'm going to have the thing as a greater than 5. This is the condition which I'm going to give. Okay. And next thing which I'm going to give is, okay, let's say if I'm going to write down, let me erase it. So let's say the constraint which I'm going to give is a less than 20. A is less than 20. This is the constraint which I'm going to give inside my parent class. This particular constraint is present inside my parent class. And in the child class, what I'm going to do is constraint range underscore 2. And here on the same variable, what I'm going to do is I'm going to write down the constraint as uh, a greater than 30. Okay, this is what I'm going to do. And this is in my child class. Now, what do you think? What is going to happen if we are going to randomize and if we are going to check what is it I'm going to have? Anyone wants to answer? Anyone wants to give it a try? Okay, so I got one answer. Is the values will be generated from 20 to 30. Okay. Any other answers? Okay. As the names of okay, as the names of constraints are different, then it will be separate for parent and separate for class 20 to 30. Okay, I have got few answers. Let us check it out. What is going to happen over here? Let me write it down quickly. Okay, let us write down in the same code only. So let's say if I'm going to give is greater than 20 is one of the constraint which I'm going to have. That is a underscore range. Okay, let me create the child class test2 test2 extends test1, and here the same code, let me write it down. or else let me copy the constraint only. No need to declare the variable since it's a child class, it will extend the variable. Okay. And here, what we have written over here, a is greater than 30, a is less than 20. A is less than 20 and here A is greater than 30. Okay. And we have a different name for my second constraint. Let's say this is range underscore 2. Range underscore 2 and this is range underscore 1. So in the parent class, we are having one condition and in the child class, we are having another condition. Okay. Now let us check what is going to happen. Let me create a child class handle also test underscore 2 t underscore h2 and let me create the object for it. T underscore h2 is equal to new t underscore h2 dot randomize and t underscore h2 dot a. Let me check what is going to happen. What happened? Line number 14 test 2. Okay, test 1. T underscore h. Okay, okay, sorry. Yeah. 7. Sorry. Okay. Yeah. I've said right previously. Test bench 23. What happened to this? Okay, it's test underscore 2. So what is it we are going to get? The value of is 0. Okay. So let me show you what is happening over here. What is happening? Randomization failed. The condition of randomized call cannot be satisfied. Why it is not being satisfied? On a same variable, what we are going to do, the value of a is less than 20 and the value of a is greater than 30. Is there any value such that which is less than 20 and greater than 30 at the same time? Is there any value like that? No. So here, if you carefully observe, randomization is getting failed. Okay. Can you able to see the message? So here we are going to get that randomization is getting failed. Okay. And if you carefully observe, let's take one variable declared. Let me show you. In the previous session, I told you right. Randomization, if we are going to call, it's a function. It's a built-in function. Randomize is a built-in function. If we are going to call, we are going to get two values, 0 or 1. If randomization, if you are going to call it and if it is returning 0, that means randomization is getting failed. Okay. Let me write it down. Let me declare a variable as success and this success, let me copy it and paste it over here. Success is equal to t underscore h2 dot randomize and let me display success also. And success is percentage d, comma, success. Okay. Let me show you. Let me display it. So the value of success will be equal to 0 since the randomization is getting failed. See? So the value of success is 0 since the randomization is getting failed. Okay. So this is how we are going to check whether the randomization is getting passed or failed without actually checking the console messages. We can check it out using the value that your randomization method is getting written. Okay. So what you can do over here, let us write it down. A is greater than 20 and A is greater than 30. Now what is going to happen? Can anyone tell me? So the value which is greater than 30 will be satisfied. Okay. Not 20 actually, greater than 30 will be satisfied. Let me show you. Let's say suppose A is greater than 20 and let's say A is less than 25 or let's say A is less than 30. So the values between 20 and 30 will be printed. Okay. So the compiler is going to follow the two conditions which we have given in the two constraints. Okay. So constraint which we have declared in the parent class will also be working, and the constraint which we have given in the child class will also be working. And in the child class, we have given some more extra condition. That's it. Child class, if we are going to declare a constraint, it is going to act as like your extra condition. That's it. Okay. Is it clear, guys? Is it clear for everyone? Shall we move forward? Okay. Okay. That's great. And one more thing over here, for the two constraints, I have given the same name, different names. This is range underscore one. This is range underscore two. What if I'm going to give, yeah, no, both the constraints are getting executed. So you can see from A is greater than 20 to A is less than 30. In between these two values, both are getting executed. Okay. So if you think like only child class constraint is getting executed, then if you have written like this, like A is less than 20 and A is less than 30, only this condition should execute now. This should not be considered, but it is considering this also. Okay. So both the constraints are getting executed. That is why I took the first example. Okay. So in these cases, both the constraints are getting executed. Now, so let's say if I'm going to have the same name for the two constraints. Let's see what is going to happen. What is happening, guys? Can anyone see and tell me what is happening if we are going to have the same names for both the constraints? What I'm getting over here? Child class is getting executed. Child class constraint is getting executed. Okay. Let me modify this value. Let's say the child class constraint A equal to 0. Let me run it so that it will be more clear. See, so the value of A is 0 only. That means if you are going to have the same names for both the constraints, then your child class constraint is overriding your parent class constraint, and only the child class constraint is getting executed. This is nothing but constraint overriding. If you want to override your parent class constraint, then you need to have the same constraint name which you have given in your parent class, so that you are going to override your parent class constraint. But if you are going to have different names, then both the constraints will be executing. There is a difference between overriding and constraints executing, both the constraints executing in the parent class and child class. Is it clear? So let me write it down in the PPT also. So there are two cases over here. Case one over here is parent is having one constraint name, let's say constraint one, and here child is having another constraint, let's say constraint underscore two. So these two constraints will be checked. These two will be checked. But in the case of our case 2, if the parent is having a constraint, let's say const underscore 1, and the child is also having the same constraint name, this is known as constraint overriding. And only the constraint which we have written inside our child will be executed. Only this will be executed. Is it clear, guys? Yes or no? Okay. So these are the two scenarios you need to be careful. One is overriding. Overriding, if you want to perform, both the constraint name should be same. And overriding in the sense, this child class constraint will be executed. Child class constraint is executed. And let's say if you want to add some more extra layer of constraint by performing the inheritance, you're going to add the constraint with some different name. That is nothing but you can say constraint inheritance. Okay. So let me write it down that one also. So coming to my constraint inheritance, constraint range underscore 2 is less than 30. Here in this case, both the constraints will be executed. This is constraint inheritance, you can say it. Okay. Yeah. Yes. Mhm. Is it clear? Any doubts or any queries in this? Okay. Now let's say, let me come into this constraint, child class constraints and all, and let me come into the constraint inheritance, and let me give some conflicting value like this. A is less than 30 and A is less than 20 and A is less than 30. So here I was getting my randomization to be failed, right? Now, so let's say, okay, what is happening? A is less than 20. Sorry, let's say A is less than 20 and A is less than 30. This is not conflicting. What is a conflicting constraint I can give? A is greater than 30 and A is less than 20. Yeah, this conflicting constraint I can give. So this is conflicting, right? And your randomization is going to get failed over here, right? Now what I can do over here, so I can use a keyword which is known as soft. So if I'm going to use a keyword which is known as soft, it is going to make sure that if there is a conflicting constraint, no issue, the child constraint will be executed. Okay. So in the case of your parent and child, if there is any conflict, then if you're going to use soft keyword, then your parent constraint will be discarded and only your child constraint will be executed. Okay. So this is the use case of your using your soft keyword. Okay. But this is not recommended. Generally, you're going to use the constraints that are not conflicting with each other. That is better. Okay. Yeah. So that was about your constraints. In constraint inheritance example, will it be different result if we call using parent class handle? Okay, let's call that also. Constraint inheritance, right? Okay. So shall we remove this soft keyword and let me give this t underscore h, t underscore h, t underscore h. Let me run it. Things are happening normally only. What is happening over here? So first constraint is A is less than 20 and second constraint is A is greater than 30. And I'm calling the randomization method using the parent class. Okay. And I'm displaying the value of A and B. So parent class object don't know about child class at all now. So this parent class handle don't know about the child class constraint. So no conflict at all. But if we are going to call the randomize using the child class knows about the parent class constraints also now. That's where the conflict is coming. Okay. Is it clear? Yeah. Can we use soft in the child? Yeah, you can use, let me show you. So let's say if I'm going to use soft over here and let me call t underscore h2 dot randomize. H2 is equal to new. Let me call the randomization again. What is happening over here? So I'm getting negative values t underscore h2 I'm calling. Then what is happening? Your parent class A is less than 20 is getting executed. Can you able to see? Okay. Yes. So this is nothing but my soft keyword, constraint overriding and constraint inheritance. Okay. Now there are two more methods in my randomization which we will discuss. So those particular methods are known as rand underscore mode. So this rand underscore mode, it's basically a function which we are going to use. And if this function argument is made to 0, then it will turn off the randomization. And if it is equal to 1, it will turn on the randomization. For example, if we are going to use handle dot rand underscore mode of 0, if we are going to pass the argument as 0, then basically it is going to then it is going to turn off your randomization. Okay, so it is going to randomization. And if you're going to use h1 dot rand underscore mode of 1, it is going to turn on the randomization. So these are the two methods which we are going to use for turning off and turning on the randomization. So let's see one example for this. So let's say here I'm going to, okay, I'm going to turn off the randomization, rand underscore mode of 0. Okay. And let me remove the soft keyword and let's check. So what I'm doing, using the second handle, I'm turning off the randomization and let me create the object for first handle also. And I'm going to call the randomization using the first handle. But using the second handle, I'm calling off the randomization. I'm turning off the randomization. T underscore h1, T underscore h only. Let's declare it as T underscore h1. So see, so if you're going to turn off the rand underscore mode, if you're going to call the rand underscore mode, and if you're going to turn off this t underscore h2 dot rand underscore mode of 0, and if you're going to call the randomize method using my t underscore h1, what is going to happen? Can you able to see? Is it going to affect the randomization on the second object? Yes, by default, rand underscore mode value will be equal to 1. Okay, let me first of all turn off it using t underscore h1. So is randomization happening? Can you see any random values that are being generated? If I'm going to call the rand underscore mode of 0? No, right? Okay. So if I'm going to call the randomize method and using the same handle, if I'm going to call the rand underscore mode of 0, randomization is not happening, right? But if I'm going to use other object t underscore h2 and if I'm going to call the rand underscore mode, that is not going to affect my randomization in the t underscore h1 handle. See, randomization is happening normally only. But I'm calling the method using the second handle t underscore h2. That is not affecting my t underscore h2. Now is it clear? Uh, you mean like this one? Yeah. So randomization is happening, and since that's the reason we are going to get one. So when you are going to get success is equal to 0, when there is a conflict and when there is a condition where, like we have seen, right? So in those cases only you will get success is equal to 0. Okay. So here randomization will be performing and we are just turning off the randomization, but there is no conflict at all. Okay, if we are going to call the randomized method, it is going to return one only. If there is a conflict, then only randomization will be failed and it is going to give success as 0. Okay, yeah. Mm. So that's about this randomization and constraint inheritance, constraint overriding, and we will see some more related concepts of these constraints in our next session.